Well, I recorded my first video and nothing caught on fire in my office. So I'm going to keep on going. I listened to myself and I could tell that my voice was a little bit high and a little bit hard to understand. So I'm going to try to speak up a little bit and see if that helps a little bit. Okay. So now that we have this graphing going on here, what we're going to do is we're going to add linear regression. Actually, there's something here that's bothering me, and I need to fix that right now. Notice that there's no data below 1 week and no data beyond 8 weeks. You really want your data and your graphs to take up the entire space. Okay, so let me show you how to do that real quick. What we're going to do is we're going to go ahead and click on one of the numbers in the independent variables. I'm going to click on my 4 here. Right mouse button. If you hear snickering in the background, that's because my good friend Dr. Mann is watching me do this. What I'm going to do is I'm going to go ahead and click on Format Axis. And the Format Axis dialog box comes out. You can see that there's a minimum and a maximum between 0 and 9. And I don't want to include 0, so I'm going to change that minimum to a 1. And I'm going to change that maximum to an 8. Okay, to an 8. And notice that as soon as you click on a different box, the axis changes on the fly. Okay. All right. Now what we're going to do is we're going to add a regression, and I'm going to choose one of these lines because your author through Carolina Biological only talks about linear regression. And the truth of the matter is that Excel has various types of regressive plots, and so you need to be able to discern which one's the best choice. And there's a very easy way to do that, and that's by using a tool called correlation on there. Okay, so let's start with this gray line right here. I'm going to go ahead and click on it. Okay, once it's selected, I'm going to click my right mouse button. I'm going to add trend line, and on the right, notice that I have some choices. I have exponential, linear, logarithmic, polynomial, moving average. I'm going to move my scroll bar down so I can see 2 things that I want to include on there. One is display equation on chart, and the other one is display R squared. That's my correlation on the chart. Okay, and the magic here comes from this R squared variable. The closer that R squared is to 1, the better the fit between our regression line and our data. So if we click on that regression line, again, the choices that we have highlighted are linear, logarithmic, polynomial, and moving average. I'm going to tell you from experience that moving average is a challenging one. I typically do not use it. So Excel is telling you that it's going to be one of these 3 that's going to work. So we notice that for linear, our correlation is 0.94. If I click on logarithmic, it went up to 0.95. Because 0.95 is closer to 1 than 0.94, it means that the logarithmic fit is better. And I click on polynomial, and look at that. My correlation went up to 0.977. That means that that's even a better fit. Now, if you look on the right of polynomial, this is allowing you to use a 2nd degree polynomial. We know that because it says order 2. If you want, you can move that to a higher degree, and that might make it better. So let's see what happens. And click to 3, and look at that, 0.98. So the higher the degree, the better the fit, but also the more complicated that equation becomes. So you have to kind of temper your enthusiasm and make sure that you don't make that equation so difficult that you can't work with it. But there is a very good fit, okay, between that equation and the data. And that's where I'm going to end this one. And I'll come back in just a little bit so I can show you how to graph this equation on your plot. Okay? Thank you.